Good morning and good afternoon. Hopefully everyone has had a great day today. Today we were going to be learning on how to solve equations, which is really closely tied to being able to solve inequalities. So without further ado, we're going to be talking about how to solve for equations with variables on one side, variables with distributive property, variables with distributive property on both sides, and variables with the x value for them on both sides. So if you look at question number one, we are going to be looking at the first one, and I'm going to go ahead and split the screen, and I'm going to have my trusty Desmos right next to me just in case I do need some help with addition, subtraction, multiplication, and division of integers. So we'll go ahead and get started with our simple equation, and then we'll move on to complicated equations. So I'm going to start off with a blue ink. So the way I handle the equations is I always want to isolate the variable. So I always want to solve for the x, even though on the STAR test, sometimes they give you answer choices of A, B, C, and D, and you're going to pick the best one. But I like to solve for the variable and the x value. So the first step on this one is I look at the equal sign and I call it a railroad track. I draw the railroad track. So whatever I do on one side, I have to do to the other side. So I always want to circle my x because I do want to isolate the 3x by itself because it comes with an x. So I got to get the 3x by himself. So in order to get the 3x by himself, I got to get rid of the positive 6. And how do I get rid of a positive 6? I do the opposite of positive 6, which is a negative 6. But if I do a negative 6 to one side, I have to do a negative 6 to the other side. And the way I like to organize my work is I like to draw a line so I can distinguish it. So if I have a positive 6 and a negative 6, that cancels out. And if you don't trust my math, then all you have to do is go 6, and then I go positive 6 minus a 6. That should give me a 0. So I'm going to go ahead and cancel it out, and this gives me a 0. This leaves me the 3x by himself. I'm going to bring down my railroad track, which is my equal sign, and the line, and then I'm going to do an 18 minus a 6. And if I know what 18 minus 6 is, it is 12. So now I have 3 times x equals 12. What is the x value? So the next step I'm going to do is I'm going to divide both sides by the number next to the letter because the inverse of multiplication is division, and I want to get rid of the 3. So in order to get rid of the 3, I'm going to divide this by 3, and I'm going to be dividing this by 3. 3 divided by 3 is 1, but that also gets rid of it, leaves you x by itself, equals to 12 divided by 3. 12 divided by 3 is 4, and my x value is 4. Now, if I don't believe myself, then I go back to the equation and I check my work. I say 3 times a number plus 6 equals 18. I substitute for the 4 to be x, so I go 3 times 4 is 12 plus 6 equals 18. That means my problem is correct. So that is a simple way of how to solve an equation. If we go to number 2, we have the same type of format. So I'm going to follow the same type of steps. I'm going to draw my line down the railroad track. And then, of course, I'm going to circle my variable, which is my letter, because I want to get 4y by himself. But I want to get rid of the negative 8 on the left side. How do I get rid of negative 8? I do the opposite. So I'm going to do positive 8 on this side. But what I do to one side of the railroad track, I have to do to the other side of the railroad track. So I'm going to do positive 8. I like to do my line so I can distinguish it and separate my work. I have a negative 8 and a positive 8. That gives me 0. That leaves me my 4y by himself on this side. And it's going to bring down my equal sign. And then I'm going to add 16 plus 8. 16 plus 8 is 24. So the way I see this is it's 4 times y equals 24. Got to get rid of that 4. So how do I get rid of the 4? I divide both sides by the number next to the letter, which is 4, and which is 4. I'm going to get 4 divided by 4 is 1, and y divided by y equals to 24 divided by 4, which is 6. And that is my answer. And if I want to check it, I go back to the equation and I input it. I say 4 times 6 is 24 minus 8 is 16. So the answer is correct. Now, if you don't believe me what 24 divided by 4 is, all you have to do is go into the decimals and put 24 divided by 4, and it gives me 6, which is the answer to 6. So that is a simple way to check your answer. If we go to number 3, problem number 3, and then I'm going to clear it so then that way I can go ahead and have clean work. If I look at that, what did I learn in my previous lesson? Well, I learned the distributive property. So the first step is to underline my distributive property so I can get it into the form that we just did. So I see the distributive property. I am going to distribute the 4 into the x and the 4 into the 5. 4 times x is 4x. And then I'm going to go 4 times 5 is positive 20. And then I'm done with that side. I'm going to bring down my equal sign, and then I'm going to put 16. Now I'm down to a simple equation. I'm going to go ahead and draw my railroad track. I'm going to circle my variable, which is a 4 times x, which is a 4x. I want to get the variable and the number by itself. So I get 4 times x by itself. I want to get rid of the positive 20 on the left side. So how do I get rid of positive 20? I do the opposite, so that is negative 20. But what I do to one side of the railroad track, I have to do to the other side of the railroad track. So then I like to draw my line, so then that way I can distinguish. You have a positive and a negative 20, cancels out. That leaves me a 4x by himself, which equals to 16 minus 20, which gives you a negative 4. So we have 16 minus 20, and if you don't believe me, put it on decimals. You go 16 minus 20, and now you don't even have to know how to subtract the integers other than inputting it into decimals, which gives me a negative 4, which is right here. Now I want to solve for the 4 times x equals negative 4, so I want to get rid of, I want to go ahead and get rid of the, right here, the 4. So what I'm going to do is I'm going to divide both sides by 4, and I'm going to divide both sides by 4 because I want to get rid of the 4. So I get 4 divided by 4 is, by itself, is 1. So x equals to negative 4 divided by 4 is negative 1. So my answer right here is negative 1. Now, if I don't know what negative 4 divided by 4 is, all I have to do is input it into my decimals, negative 4, right here, divided by 4, and it gives me negative 1, which is my answer. And then if I want to check it, all I do is substitute into the equation, the original equation, and then that will give me the correct answer. So we are going to do one similar, which is number 4. Okay, so the next problem, first step, is that we are going to underline our distributive property. So we are going to underline this entire item because we're going to use the distributive property. We distribute 5 times x, and you have 5x. And then you distribute 5 times negative 3. And once again, you can input that into the decimals and let the decimals do the work. 5 times negative 3 will give you negative 15, which equals to 25. Now we go back to a simple equation where we have a variable 5x. We have 5 times x, which is a variable of x, minus 15 equals 25. So what I'm going to do next is I'm going to circle the 5x, and then I'm going to do my railroad tracks. And I want to get rid of that negative 15 on the left side. So how do I get rid of the negative 15? I'm going to add 15 right there to get rid of it. But if I add 15 to the left side, I have to add 15 to the other side of the railroad track. Because what I do to one side, in order to balance the equation, I have to do to the other. So I have a negative 15 and a positive 15. I get rid of that. And that gives me a 5x. And of course, I like to draw my line. I'm going to leave the 5x by himself, which equals to a total of 25 plus 5, which get 15, which gives me 35, 40. And now I want to get rid of the 5. So I'm going to do the opposite of multiplication, which is a division. I'm going to divide both sides by the number next to a letter, which is 5. And I'm going to divide that side by 5. So 5 divided by 5 is 1, which gives you a 1x, equals to 40 divided by 5, which is an 8. If you don't believe me, you can go ahead and input that on the Desmos, and of course you can substitute it all the way up to the top equation, and then you put x is equal to 8, so you put 5, and then you open parentheses 8 minus 3, which gives you 5. 5 times 5 is 25. The answer is 25, which is correct. So your solution is x equals to 8, which is correct for the answer. So next, I'm going to be doing it without Desmos because, of course, if you need the multiplication practice or the division practice or the addition or subtraction, then you just input it onto the Desmos. And I will go ahead and make a note in case you do need to input it into the Desmos. So now we are going to do variables on both sides. Now you have a 6x on one side and a 2x on the other side. Then I have a positive 10 on one side and the 2. So the goal of this type of equation with variables on both sides is to isolate, get the x's on one side, and I get the numbers to the other side so I can solve the equation. So what I do first is I'm going to get rid, and I always want to get rid of 1, so I always underline which one I want to get rid of. I want to get rid of a positive 2x. If you don't know that this is a positive 2x, you can always put a plus sign in front of the 2 so you can understand that it is positive 2. So my next step is in red. I'm going to put, how do I get rid of a positive 2x? Well, I do a minus 2x. But what I would do to one side of the railroad track, I have to do to the other. And I recommend to align it right underneath the x's because remember, you can only subtract cows with cows, ducks with ducks. And then what I do is I like to do my line, and excuse that. I like to do my line like that. And then I go 6x minus 2x, which gives me a total of 4x. And then I'm going to just bring down the positive 10. I'm going to bring down my railroad tracks, the equal signs. And then I have a positive 2x and a negative 2x, which gives me a total of 0, because they do cancel out, which gives me a 2. Now I'm down to my simple multiple step equation, the one-step equation with variable on one side. So I'm going to circle the 4x. And then I'm going to want to get rid of that 10. So I'm going to draw my railroad tracks again. And I want to get rid of the 10, the positive 10. How do I get rid of positive 10? I subtract 10. But if I subtract 10 to that side, I have to subtract 10 to that side. And then I like to draw my line so I can know where my work is. I have the 4x by himself down here. And then I get a positive 10 and a negative 10. Give me a 0. They cancel out. Bring down my equal sign, and I have a 2 minus 10, which gives me a negative 8. Now, if I don't know what to do 2 minus 10, all you do is put it in Desmos, 2 minus 10, and it gives me a negative 8. The last step is to go ahead and isolate the x. So I have a 4 right there. So that is like multiplication. So the opposite of multiplication is divide both sides by the number next to the letter. And the number next to the letter is the 4. So I'm going to divide by 4 here, and I'm going to divide by 4 there. 4 divided by 4 is 1. 1x equals 2. A negative 8 divided by 4 is going to give me a negative 2. And of course, if you don't know how to divide negative 8 divided by 4, all you do is input it in Desmos, and Desmos will pop out a negative 2. Next, we have a different variable with variables on both sides. So the first step is to draw my railroad track so I can know that, hey, that's one side, I gotta balance the sides. The next step is to get rid of this 7x. So I'm going to underline what I want to get rid of. I want to get rid of the positive 7x. So then how do I get rid of positive 7x? I do the opposite of 7x, positive 7x, which is negative 7x. But what I do to one side of the railroad track, I got to do to the other side of the railroad track. And then I like to draw my line, so then that way I know, okay, my work is over here. I have a 4x minus a 7x gives me a negative 3x. And how do I get that? I just input 4 minus 7 on Desmos. Should give me negative 3x. And I cannot input my x's. The only thing I can input on Desmos is 4 minus 7, which gives me a negative 3. But I know that they're x's, so I keep a negative 3. Then, of course, I bring down the negative 5. And then I bring down my equal sign, and I have positive and a negative 7x. That gives you 0, and that gives you a positive 10 on that side. So now that I'm down to a simple equation, So now I'm going to draw my railroad track right here. Then I'm going to circle, and you cannot forget to circle the whole entire negative. So I want to get negative 3x by himself. So how do I get negative 3x by himself? I got to get rid of the negative 4, negative 5. How do I get rid of the negative 5? I do the opposite of negative 5, and I do a positive 5 on that side. I do a positive 5 on that side. I get rid of negative and positive 5. I like my little line here so I can distinguish how to do the work. And that leaves me a negative 3x on this side. The negative and positive 5 give me a 0. And I'm going to bring down my equal sign. And then a positive 10 and a positive 5 gives me a positive 15. And then I'm down to the last step. I got to isolate the x. So I divide both sides by the number next to the letter. And the number next to the letter is negative 3. So I got to divide that side by negative 3. And I got to divide that side by negative 3. Be very careful that you're not just dividing by 3, because then you don't cancel out the negative and the answer will be wrong. So you got to divide both sides by a negative 3. So a negative 3 divided by negative 3 gives me 1, which gives me x equals to the 15 divided by negative 3. 15 divided by negative 3 is a negative 5. And that is my answer. And you got to be careful because of 15 divided by negative 3, you have different signs. You got to keep the sign of the negative. But again, you can just input it into the Desmos, and the Desmos will do it for you. You can even input negative 3 divided by negative 3. Negative 3 divided by negative 3 is a positive 1, which gives you the 1x. If you look at problem number 7 in the equations, I'm going to go ahead and delete the work above. We have another equation with variables on both sides. So I'm going to take you through the steps one more time. And we're going to draw our railroad track. We're going to underline the 4x because that's the one we want to get rid of. And that is a positive 4x. I want to get rid of the positive 4x. So I'm going to subtract 4x to that side. But what I do to one side, I have to do to the other side. So that is a negative 4x right there. So then I'm going to draw my line because I like to make sure that I know the work on the top and I don't get myself mixed up. So you have on this side, you have a 9x minus a 4x. 9x minus 4x gives us a positive 5x. And of course, if you don't believe me, you can input it in Desmos, and Desmos will do it for you. You bring down the negative 1, and then you bring down your equal sign. You have a positive and a negative x, 4, and that cancels out to 0. And then you have a 14 by itself. Okay, then the next step is 5x minus 1 equals 14. Then what I'm going to do in green is I have a simple equation. I'm going to draw my railroad track. I'm going to erase the stray mark, draw my railroad track, and then I'm going to circle my 5x. I want to get rid of negative 1. So how do I get rid of negative 1? I am going to add 1, which is the opposite. But if I add 1 to that side, I have to add 1 to that side. I'm going to go ahead and draw my line. And so that leaves me 5x by himself on this side. A positive and a negative 1 gives us a 0. Bring down my equal sign. I'm going to have a 14 plus a 1 gives me 15. And then all of a sudden I have 5x equals to 15. Then I'm going to divide both sides by the number next to the letter. The number next to the letter is 5 because I want to make sure that I isolate the x by himself. 5 divided by 5 is 1x, which gives you 15 divided by 5, which is 3. And that right there is my answer. If I don't know what 15 divided by 5 is, then I can go ahead and input it into the Desmos. I have another problem right here. I'm going to do the same steps. I'm going to go ahead and draw my railroad track. And I'm going to underline the x I want to get rid of. So I have to pick the 5x or the 2x. If I pick the 5x, I have to throw it to that side. I pick the 2x, I have to throw it to the other side. So I want to pick that one. So I want to get rid of that one. So I'm going to do the opposite of positive 2x. I'm going to do minus 2x. But then if I do minus 2x on that side, I got to do minus 2x to that side. I'm going to draw my line so I can distinguish what it is. And I always want to be careful that I align the x's with the x's and the numbers with the numbers. Remember, you got to align the cows with the cows and the ducks with the ducks and the chickens with the chickens. So you have 5x minus 2x, which gives me a total of 3x. And then you bring down the 12, positive 12. I bring down my railroad sign, which is the equal sign. So I have my equal right there. I have a positive and a negative. That gives me a 0. and then that gives me a 6 on that side. I'm down to a simple one-step equation. So what I'm going to do is I'm going to do my railroad track. I'm going to circle my 3x because that's the one I want to get rid of I want to get him by myself. So how do I get 3x by himself? I got to get rid of the positive 12. How do I get rid of positive 12? I got to do the opposite of positive 12, which is a negative 12. But if I do negative 12 to that side, I got to do negative 12 to that side. And then I'm going to draw my line so I don't confuse myself. And once again, once you get these steps, you can skip some steps. But for the first time that you do all the work, you have to make sure you show your work until you understand the problem. You get rid of that, and it gives you 3x equals 2. You have a 6 minus a 12. 6 minus 12, you put it on decimals, and it should give me a negative 6. If you don't believe me, then go ahead and put it on decimals. Then we have 3x equals to negative 6. I'm going to divide both sides by the number next to the letter, which is 3. And I'm going to divide both sides by 3 because the inverse of multiplication is division. 3 divided by 3 is 1. X equals to negative 6 divided by 3 is a negative 2. And that right there is your answer. Now let's see if we have another one of these. So now we're going to get into a little bit more complicated. Now look at this problem. This is a real good problem. Why? Because we have distributive property on one side, we have distributive property on the other side, and then we got numbers, and then we have combining like terms. So this is going to turn into one of those juicy problems. So the first step on this is, first of all, we got to underline the distributive property. So I am going to underline it in blue. So I have my distributive property there, I have my distributive property there. So the first step is to simplify the distributive property. And what did I do? I have to distribute like that. And you have 4 times 3x, which gives me a 12x. And this is going to take a little work because you go 4 times negative 5. You don't know what 4 times negative 5 is. Just put it in your decimals. And I'm not going to put it in. It's going to be negative 20. And if you want to stop the video and put it in your decimals, you're more than welcome. Then here is a positive 6 by himself. You bring him down, and then you put equals 2. And then I'm going to distribute right here. I'm going to do it in green because there's a distributive property. And distributive property, you have a total of 10x. 2 times 5x is 10x. 2 times positive 7 is a positive 14 because you are multiplying 2 times 7. Then you bring down the negative 4. Now, my recommendation is to rewrite it using combining like terms before you get the variables on both sides. So my recommendation from here, you can do any recommendation you want as long as you come up with the right answer. So my recommendation from here is to underline all the like terms on one side and all the like terms on the one side and then combine them first. So right here I have a negative 20 and a positive 6. Those are my like terms there. On the left side, I have a positive 14 and a negative 4. So I would rewrite this equation with 12x and then a negative 20 positive 6 will give me a negative 14, which equals 2. I have a 10x and then I'm going to bring that down. I brought my equal sign down. And then I have a positive 14 and a negative 4. A positive 14 and a negative 4 gives me a positive 10. Don't believe me? Then go ahead and put it on decimals. Now, if you see that black, I see that now I have a variable on both sides. So we did that type of equation already. So what I'm going to do, and I'm going to do it in green, is I'm going to draw my railroad track, and then I'm going to underline which x I want to get rid of. And in this term, I want to get rid of 10x. So I want to get rid of positive 10x. How do I get rid of positive 10x? I'm going to subtract 10x to this side. And I'm going to subtract 10x to this side. But if I do positive 10x and a negative 10x, that gives me a 0. I'm going to draw my line so I don't confuse myself. Then I have a 12x and a minus 10x. That right there in blue will give me a 2x. So I have a 12x, I have 12 cows, and I take away 10 cows. That gives me 2 cows, or 2x's. Then I bring down my negative 14. I bring down my equal sign. I did the positive 10x and the negative 10x, which gives me a 0, and I leave the 10 by himself because that's all that's there. So then I have my simple one-step equation. So in green, or let's put it in black, I'm going to go ahead and draw my railroad sign number 1, and then I'm going to go ahead and circle my 2x. Now I want to get rid of the negative 14, not just 14. You got to get rid of negative 14. How do I get rid of negative 14? I do the opposite of 14. So I'm going to add 14 to that side, and I'm going to add 14 to that side. I'm going to get rid of negative and positive 14. I like to do my line. Positive and negative 14 give me a 0. That gives me to 2x equals to 24. But then again, I am not done because now I have 2 times x equals 24. I got to get rid of that 2. So I'm going to divide both sides by the number next to the letter, which is 2, and which is 2. And then so that gives me as x equals to 12. Don't believe me that 24 divided by 2 is 12, then go ahead and put it in your Desmos, and the Desmos will do the work for you. And the last problem I'm going to be going over is this one, which is very similar to the problem before that. So if you look at that problem number 10 with blue, I'm going to go ahead and underline my distributive. I'm going to underline my distributive. So the first step is I like to draw my railroad sign. So then I'm going to go down and I'm going to say, well, I got to distribute first to start shrinking the puzzle down, and we can start simplifying it and solving it. So as you see, it's like a puzzle. So then we're going to distribute here, and we're going to distribute here. And then you think about it and you say, well, what is 5 times 2x? 5 times 2x is 10x. And then I do 5 times 1, it is 5. And then the negative 3, you're just going to bring it down by itself. You're going to put down the equal sign. And then the next step is you're going to distribute in green, and you're going to distribute in green. You're going to distribute 3 times 3x, which gives me 9x, and you're going to distribute 3 times negative 2, which gives me a negative 6. Don't believe me that 3 times negative 2 is negative 6. Go ahead and put it in Desmos, and Desmos will do the work for you. And then, of course, you cannot forget that positive 4. And what I like to do is I like to combine like terms here first. So I can even draw the line to go ahead and say, hey, let me see where I can combine like terms. So in black, you're going to see that positive 5 and negative 3 are the same, and the negative 6 and the 4 are the same. I can draw my railroad sign, so then I can say this side I'm going to combine, this side I'm going to combine. The 10x, there's no combining like terms, so I'm going to leave it as is, 10x. And then I'm going to combine positive 5 and a negative 3. A positive 5 and a negative 3 is a positive 2. And then I'm going to put the equal sign, and then I'm going to bring down my 9x, which is this one right here. And then I'm going to do the negative 6 plus a 4. Negative 6 plus 4 is negative 2. So if you don't believe me, then just go ahead and input it in Desmos. The next step, now I'm going to get a different color, and I'm going to go back to blue. No, let me get to the red. And then I'm going to do my railroad sign. Now I have the variable on both sides. So I have a 9x and a 10x. I decide which one I want to get rid of. I want to get rid of the 9x. So I am going to get rid of 9x. How do I get rid of positive 9x? I do the opposite. I get rid of it by going 9x negative on that side. But if I do negative to that side, I got to do negative to that side. And then, of course, I draw my line, so then that way I can distinguish the steps. 10x minus 9x, you have 10 cows, and you take away 9 cows. You only have 1 cow, which is the same as 1x. And if you want to put the 1 and it makes you feel better, you can go ahead and put it. You do not have to necessarily put it, so I can erase it. It's already x. And then, of course, I'm going to bring down just the 2, so it's positive 2, which equals 2. You have a positive 9x and a negative 9x. That gives you a 0. That's going to give me a negative 2. So then I have x plus 2 equals negative 2. Now, this makes it an easier step because guess what? I don't have a number next to the x, so then that means once I solve for this, I'm going to have the answer. So I'm going to circle my x. I'm going to get the positive 2 out of the way. I'm going to do my railroad sign and circle my x. I want to get rid of positive 2 on the left, so I'm going to do the opposite, which is negative 2. and then I'm going to do the negative 2 on this side. Get rid of that. And then, of course, x equals to negative 2 minus 2, which gives me negative 4. And if you look at that right there, if you don't know how to do that, let me show you one more time. You go into your Desmos and you put negative 2, and then you go minus 2, and it gives me negative 4 on Desmos. So once again, Desmos will always, always, always do the work for you. You don't know what 6 minus 3 is, Desmos will do it for you. And then you just exit out. You don't know what 9 minus 15 is, well, Desmos will do the work. It is negative 6. You don't have to get confused. If you don't know what negative 20 divided by 4 is, Desmos will do the work for you, which is negative 5. So anytime now, you don't have to be scared of fractions. You don't have to be scared of decimals, because Mr. Desmos will do everything for you. So if we can go back here, we have our equation and we have our answer right away. So once again, this was a brief overview of our 10 questions. I know we have some more practice problems that we should be doing, but again, the steps continue on with the same process and the same steps. And then when we get into inequalities, which is going to be in a later video, we're going to talk about the less than and less than sign, greater than sign, less than or equals than sign, greater than or equal to sign. And then if you look at the inequalities, it's the same exact thing, except it's the same process, except just putting, that's all it is. If you put an equal sign, it's the same type of process. But in this regards, there's only the less than, greater than, or equal to sign. So we'll have an additional lesson for this type of equation with inequalities, but it's practically the same thing. And at the very end, if you divide or multiply by a negative, then after that you have to flip the sign. That is the only change to the rule, but everything else, the sign just keeps on going down with the problem. Well, I hope this was very, very informative for you. And of course, if you need any support on anything, we have problem number 11 and 12. If you want to pause the video and try those two problems out, you're more than welcome to. And I will do these problems in a later video. So I hope you have an amazing day and keep up the great job you are doing with Algebra 1 and the math that we are learning here together. Thank you for your time.